Welcome again to the video on the power quality over here. Here in this video again we discuss the part of the two-wire passive compensator, and we will discuss that a Phasor diagram where the VL and VS will be equal. Just to recap, the current IS is flowing through the RS and ILS, which is the transmission line resistance and inductance, and here the load is represented by admittance instead of impedance, right? So impedance is usually Z. When we write admittance, it is 1 by Y, or we can say Y is equal to 1 by Z, and then we can rewrite this as in terms of G minus JBL. Now when this VL, we have to take the VL as a reference right now. If we take it as a reference, then whatever we will do, we will multiply with VL, this GL value, VL with BL value, right? So here we have the phasor diagram. Let me try to put both in the same screen. So here we will have the phasor diagram of two-wire passive compensator and the voltage regulation, load zero voltage regulation at the load terminal, the phasor diagram for that. So we will take the reference as the VL. So VL is taken as a reference. So VL is multiplied with the GL. There is no J term. So this VL and GL is in the same axis, or the positive X axis. Similarly, the VL and BL is multiplied. So it's a multiply with the minus of J. So we have a negative J axis. So what we have is you have positive X and negative J. And this admittance when multiplied with IVL will give the value of IL. So we have the resultant is the IL current. So this resultant, what we get is IL. Now we have another thing that VL can be multiplied with the JBC. It's a positive J over here. So we need to give some value so that IC will be there. So IC and IL will give rise to value of IS. So now this IS is here. If I correlate this with the power factor correction of the load terminal, the IS is in line with the VL. If the power factor correction at the substation, the IS is here. So we can find that the more we, here it is straight and here it is like angle with some tilted angle in the positive, here it is more tilted. So the capacitance value required is a little bit more in case of zero voltage regulation. And this IS usually, and we do the phasor diagram that use, if you you put a KVL, that VL addition with RS and LS, if you add these three voltages, you will get the value of the VS value. So now we take this VL, ISRS, and these three we add, and that we get is the VS value. So by this, we can say that if we put a dotted line, this VL magnitude and the VS magnitude both are equal. So the load voltage and the source voltage are same. So zero voltage regulation is attained by keeping the IS in the direction here like this. So this is the explanation of the phasor diagram for the and comparison of the phasor diagram in case of zero voltage regulation, in case of power factor correction at substation, and the power factor at the load terminal. In the subsequent video, we will do the numerical analysis of this.